two parametric functions x of t, y of t. And we graph it, so it looks something like this. And what do we do when we want to find the slope and the concavity? So what we have to do when we find that is we have to find dy over dx and d squared of y over dx squared. So how do we do that? Dy over dx would be equal to dy over dt over dx over dt. So what does that mean? That means that we have to find the derivative of x of t and over t and derivative of y over t y of t over t. So we just differentiated it. That's the way you differentiate any equation. So we just find x prime of t and y prime of t, and just take y prime of t over x prime of t. But now how do we find the second derivative? The second derivative is d squared of y over dx squared, which you might think you could just take d over dt of dy over dx, but that won't work because you're looking for d squared of y over dx squared, not d squared of y over dx dt. So what you have to do is you have to take dy dx, you have to take d over dt of dy dx, and then you have to take all of that and divide it by dx over dt. That's how you find the second derivative. And to show you what I mean, let's go through this practice problem. So if x of t is equal to 4x and y of t is equal to 6x squared, how do we find the slope and the concavity at t equals 3 seconds? So to find the slope, we've got to find dy over dx. dy over dx is equal to dy over dx. So let's find dy over dt and dx over dt. So dx over dt would just be the derivative of 4x, which is 4, and dy over dt would be the derivative of 6x squared, which is 12x. Then all we have to do is take 12x over 4 over 3x. It's just that easy. And now to find the second derivative, take d squared of y over dx squared. And to do that, we gotta use this formula right over here. So we take d over dt, dy over dx, over dx over dt. So we already know what dy over dx is, and that is 3x. So we take d over dt, 3x, over dx over dt. We know dx over dt is 4. So from that we can get 3 over 4. That would be the concavity, and that would be the second derivative. So it's always gonna be concave up at t equals 3 seconds, and the slope is gonna be 9, because 3 times 3 is 9.
Today we'll be taking a look at arc length in parametric mode given x of t and y of t, both of which differentiable on the interval a less than or equal to t less than or equal to b, and we'll be finding the arc length from this formula. We'll be doing s. The arc length is equal to the integral from a to b of the absolute value of b dt. Now, we know that the absolute value of the velocity can be also given by this. Square root of dx over dt squared plus dy over dt squared. So we can substitute this into our main equation over here to follow it. So doing s equals integral from a to b of, substituting this in, square root of dx over dt squared plus dy over dt squared dt. Now we have this function over here, x of t equals 4t and y of t equals 3t squared. We need to find the arc length from t equals 2 to t equals 5 seconds. So let's try to integrate this into here. We know a is equal to 2. We'll write our nose right here. We know b is going to be equal to 5. And we know x of t and y of t, so we can use that to find dx over dt and dy over dt. So x of t, if you take the derivative of that, you get 4. dx over dt equals 4. If you do the y of t equals 3t squared, we get dy over dt equals we can use the power rule, and that gives us 6t. Now from there, we'd substitute into this arc length formula to find the arc length, or the length of the arc, from 2 to 5 of this set of parametric equations. So our arc length will be equal to the interval a, which is 2, the 5, the root of dx over dt squared, which is going to be 16. And then we have dy over dt squared, which is going to be 6t squared dt. We can simplify this out to give us angle from 2 to 5 of the square root of 16 plus 36 d squared dt. Now, usually, if you were doing this on a no calculator portion, you might be able to factor this out, or you might just leave this as the expression for the arc length. If it was on calculator mode, then you can probably take out your calculator, plug this in, and find the power of the arc length. And don't forget to include your units. So thank you for tuning in today's lesson. This was how to find the arc length given parametric equations, and I hope you have a very good rest of the year, and good luck on your calculus exam.